Hey Kipsters, today we're going to be working on Module 4, Lesson 21, some facts about the graphs of linear equations into variables. Very much like the previous lessons, this is going to be a staple lesson for Algebra 1. In this lesson, you're going to learn another way to calculate or to identify the equation of a graph given a line. So I want you to think back to the previous lesson as we look at example number 1. Given line L, what is the linear equation of this graph? So we have to ask ourselves, can we easily identify our y-intercept and our slope? Well, I noticed that it's not impossible to locate points on the graph. I've actually identified 2 points on the graph, so it makes it kind of easy to calculate slope. However, when I'm looking at my y-intercept, my lines don't necessarily cross at a whole number, so I can't easily identify it from the graph. I don't want you to get in the habit of guessing. Let's only use y-intercept for sure when we see whole numbers or when those half intervals are given to us. So what do we do, Mrs. Matthews? Well, we can use what we've been given and we can just go ahead and calculate our slope. Remember from the previous lesson for slope, we took the distance of points P and R, we subtracted their y values, and we put that over the difference between their x values. Switching over, you can continue to use the variables P and R, or you can use the variables y and x. So remember, slope is the distance between y2 minus y1 over x2 minus x1. All right, so I'm going to label points P and R, and let's calculate this slope. So I have ordered pair, and I'll pull out the ordered pairs so you can see them better. P is located at -2, 2, and R is located at 5 and 4. You want to make sure your points are on the line. All right, when you stack your ordered pairs like I've done so, it's easier to say y2 minus y1. So 2 minus 4 over x2 minus x1, -2 minus 5. I'm going to continue to work vertically. All right, also add my calculator to attend to precision. 2 minus 4. 2 minus 4. And -2 in my numerator. And in my denominator, -2 minus 5, -7. Okay, so my slope is the fraction -2 over -7. Remember, when I see two negatives being divided, that's actually a positive. Now we need to determine the y-intercept of this line. We know that it's a point with the coordinates 0 and B, okay, where B is that number that crosses the y-axis, and we know that the point goes through the order pair -2, 2 and 5, 4. It has a slope of 2 over 7. We can use this information to determine the coordinates of the y-intercept. All right, so recall what it means for a point to be on a line. It means that the point is a solution to the equation. So when we're talking about, and I'm going to go to the top of my paper, slope-intercept form, we should be able to use an x and a y as a solution, and m is our slope. This should help us find the value of b. So we have found 2 points that represent variables x and y that we should be able to then plug into this equation to get b alone. So I'm going to go over to some scratch paper. I recommend that you do too. So because the line goes through both points P and R, it doesn't matter which point I use to plug into this equation to begin to solve for B. So I'm going to start with point P because it looks the simplest. So I've written the equation like I've been given. Instead of the variable y, I'm going to use P's y, which is 2. So 2 is equal to, instead of the variable m, I'm going to use my slope of 2 over 7. 2 over 7. And instead of the variable x, I'm going to use some parentheses so the fractions don't get confusing. I'm going to use the x for p, which is negative 2. And then I'm solving for b, so I should just write down plus b. All right, now let's begin to calculate some math. So on my left is as simple as it can go, but my right, remember we multiply fractions straight across, so this is negative 4 over 7 plus b. Remember, in this problem, I'm solving for b, so I want to use a property of equality to move this negative 4 over 7 to the left. I'm going to add 4 over 7 to the right, and I'm going to add 4 over 7 to the left. On the right, they cancel out, and I'm left with just b equals. So b is equal to 2 plus 4 over 7. So you can use your calculator. Mine looks a little different from yours, but I'm saying 2 plus 4 over 7. And it's going to give me the whole number 2. And 4 sevenths is equal to b. Let's go ahead and turn this mixed number into an improper fraction. Remember, we do that by multiplying our denominator by our whole number. I'll get 14, and then I'm going to add my numerator. 14 plus 4. B is going to be 18 over 7. Now, this should work if I use the other point. So I am going to come over here to the right-hand side. I'm going to use the other point of R to model that. We should get the exact same B. So in over 7. So going back to the original equation, now we know that B equals 18 over 7. What's the linear equation of this line? This line's equation is y equals 2 over 7x plus 18 over 7. Let's move to example number 2. Let a line L be given in the coordinate plane. What information do we need to write the equation of this line? Yep, we need to know the slope. So we need to identify 2 points so we can calculate that slope. Let's identify the point -1 and 4. Call that point P, and 4, 1. I'm going to call that point R. A couple seconds, make sure your paper looks like mine. All right, calculate the slope of the line using this formula. 3. My denominator simplifies to -5, therefore slope is -3 over 5. Determine the y-intercept of the line. So we should be able to take our any ordered pair, take point P, -1 and 4, and I'm going to use it to find my B. So instead of y, I'll be using 4, and instead of x, I'll be using -1. 4 minus 3 over 5, which is 3 and 2/5. My footer's getting in the way, so I'm going to come up. So 15, 5 times 3 is 15, plus 2 is 17. So B equals 17 over 5. Back to the question, what is the equation to this line? The equation to this line is that y equals negative 3 over 5x plus 17 over 5. Putting that down at the bottom, I've kind of run out of space. If you have 2, that's okay. Go ahead and try example 3. So in example 3, it'll be a little easier to work if you go ahead and create your y-axis either on the right side of the paper or the left side of the paper like I have. Let line L be given in the coordinate plane. Assume the y-axis intervals are 1. Okay, so that's why we've given our y-axis up on the right or on the left. What information do we need to write the equation of this line? Yet again, we need to know our slope. So we need to identify 2 points to calculate that slope. Once we calculate our slope, we can use at least 1 point to determine the equation of the line. Let's identify the 2 points on the line as 12 and 2. And R can be 13 and 7. Using these 2 points, calculate the slope of the line. You're stuck getting started. The equation for slope is y2 minus y1 over x2 minus x1. Give it about 30 more seconds. Because I see 2 negatives being divided, I know that the slope is going to be a positive 5. Now I want to determine the y-intercept point of the line and write the equation in slope-intercept form. Which point do you want to use to determine the y-intercept or the b? You can use either point. I'm going to use P just because it's at the top. All right, so I'm going to give myself a little divider, and I'm going to start with the given equation, and I'm doing some substitution into, and I'm going to write P above it, 12 and 2. Equation should look like Q equals 5 times 12 plus B. I'll use this information to say that the linear equation that represents this graph is y is equal to 5x minus 58. Example number 4. In example number 4, we want to do the exact same thing. We want to determine the line, the linear equation that represents the graph of this line. Let's use the points 3 and 1 and the point -3, -1 as reference points for this line. What information do we need to know to begin to draft the equation of this line? We need to know our slope. So I've identified my 2 points that I'm going to use to calculate slope. Slope of this line is going to be 1 over 3. All right, we need to identify our y-intercept. Lucky for us, our y-intercept goes through our origin. So if you can easily identify where your y-intercept is, you can do like we did in the previous lesson. So my y-intercept is located at 0, 0. I can use this information to then create a y equals mx plus b, a slope-intercept form equation by saying y is equal to slope plus where it crosses the y-axis, or in simplified form, y equals 1/3 x. Write the equation for the line shown in the figure. What's the first thing I need to do to begin to write the equation of this line? I want to calculate my slope. I do that by identifying 2 points. Identify the point -1 and 3. -1, -3. And I'm going to identify the point to -2. Call one P. Call one R. I then find that the slope of this line is what? Slope of this line is 1/3. Is my y-intercept easily identifiable? No, it's in between -2 and -3. Not sure exactly what number it would be when I am unsure of what my y-intercept is, but I'm sure of what my slope is. What formula should I use? I should use slope-intercept form, because my intercept is what I'm needing to find. So I'm going to substitute either P or R into this equation to find B. -2 minus 2/3. So I should be doing -2 minus 2/3. I'm actually going to get -2 and 2/3. Now, when I do that math, remember we want to multiply our denominator by our whole. It is a whole number, so 3 times 2 is 6. 6 plus 2 is going to be 8. So I'm going to get -8/3 as my B. So the equation that represents this line is what? Y equals 1/3 x minus 8/3.